My dear students, we shall discuss about the basic concept of reflection and deviation because of single mirror. You are taking a single mirror, light ray is incident and reflected back. Okay, so this is called as incident ray, this is called as reflected ray. Okay, angle made by the incident ray with the glass, with the mirror, is taken as angle of glancing or glancing angle. So G and G are said to be glancing angles here. Okay, this angle of incidence, angle of reflection. Now let us see here what is going to happen. So now here, let us discuss some of the concepts which we are going to learn today. So here, this is angle of incidence, this is angle of glancing. Angle of incidence plus angle of glancing is always equal to angle of reflection plus angle of glancing, and these two are combined together always 90 degrees. Some of these, because this is normal, these two are 90, these two are going to be 90, same. Okay, now, so here, what are the properties of reflection? First thing is, always angle of incidence, angle of reflection both are same. Okay, that means if both are same, then incident glancing angle and reflected glancing angle are also going to be same. These two are going to be same. Now let me discuss about deviation because of a single mirror. What do you mean by deviation because of a single mirror? This is called as deviation. Light ray has to travel like this, but it is reflecting in this way, and that's why this is called as a deviation. Now we shall discuss about what is this deviation. To understand the deviation, first thing is this angle plus deviation. I plus R plus delta is equal to 180 degrees. Okay, I plus R plus delta is equal to 180, and you all know angle of incidence is equal to angle of reflection. So we can take I plus delta is equal to 180. So delta, this I plus I is nothing but 2I. So therefore, we can write this as 180. We can write this as 180 minus 2I. Okay, delta is equal to 180 minus 2I. This is going to be the deviation. Okay. My dear students, we shall discuss about deviation because of two mirrors. Let me discuss, there are two mirrors. This is mirror M and M dash. One light ray enters in this direction. Okay, this is said to be P, Q, R and S. It enters like PQ, QR and RS, it exits. Now, he is asking us to find out what is the deviation. What do you mean by deviation? It is entering from here and exiting from here. It is entering like this and exit is in this direction. And that's why that is going to be the deviation here. So we need to find out the deviation. Let us consider this angle is going to be exterior angle, external angle. Now, let us imagine this is alpha, alpha dash and alpha. This is beta, beta dash and beta. Already I told you one thing. What is that? A light ray incidence and it reflects. Okay. Now this is going to be the normal. I said this is said to be glancing angle. This is said to be glancing angle. And this is a mirror. And angle of incidence and angle of reflection are going to be same here. Glancing incidence and glancing reflections are going to be same here. So these two angles always same. You just remember that one. Okay. So let us see what is going to happen now. So in this case, here you can take alpha plus alpha dash plus alpha is equal to 180 degrees. So these three angles are 180 degrees because this is a straight line. So can I write alpha dash is equal to 180 minus 2 alpha? Because alpha plus alpha is nothing but 2 alpha here. Okay. So alpha dash we got it as 180 minus 2 alpha. Similarly we can write beta plus beta dash plus beta is equal to 180 degrees because this is going to be the straight line here. Then we can write beta dash is equal to 180 minus 2 beta. Okay, you just remember these two things here. You have to remember these two things. You have to take into consideration these two things here. Now, one more thing here we have to understand is, you can just see exterior angle is equal to, this exterior angle is equal to sum of interior opposite angles, that is alpha dash plus beta dash. Exterior angle is equal to sum of interior opposite angles. Therefore, you take exterior angle. Alpha dash can be taken as 180 minus 2 alpha. Okay. Plus beta dash can be taken as 180 degrees minus 2 beta. So what are we going to consider now? Exterior angle. So exterior angle will become 180 plus 180 is nothing but 360 degrees. Here common out 2 here, you will be getting how much? If you common out 2 here, you will be getting alpha plus beta. Okay. Now, if you consider here in this case, we all know alpha plus beta plus theta. These three angles is going to be 180 degrees. So can I write alpha plus beta is equal to 180 minus theta? This is equation number 1. This is going to be 2. I will substitute 2 in 1. Let me see what I am going to get now. 2 I will substitute in 1. Let us see what is going to give me. This is here. So exterior angle is equal to 360 I will write minus, okay, 360 I will write here. 2 into alpha plus beta means it is going to be how much? 180 minus theta. Here I will be writing 2. It is 180 minus theta. So therefore exterior angle is equal to 360. 2 into 180 is again 360 minus 2 theta. I am getting 2 theta. I am getting 2 into theta, 2 theta. 360 gets cancelled. So exterior angle, how much I am getting now? This exterior angle I am getting it as 2 theta. But my aim is to find out the deviation. How am I going to get the deviation now? So therefore deviation delta is equal to, total is 360. Total is 360. I am subtracting E. From 360 if I subtract E, I will be getting delta. So 360 minus exterior angle. So therefore deviation is equal to 360 minus E is nothing but double. Always exterior angle is double to that of angle between the two mirrors, isn't it? If theta is 60, exterior angle is going to be 120. There is one previous year question regarding this also. So this final step you have to remember now. This is our final step which you have to remember here. So deviation is equal to 360 minus 2 theta. Thank you very much. My dear students, this is a previous year question regarding reflection. You can just see these two mirrors are there, OM and OP. Light ray enters from here, PQ, it strikes the first mirror, then reflects, strikes the second mirror, then reflects and comes out. It comes out along the direction of RS. So PQ, RS is the direction of light ray. And now when the light ray incident on the first mirror, this is the second mirror, it incidents with an angle theta, it takes double reflections and comes out. And it is said in the question that, what it is said, the reflected ray is parallel to the first mirror. This means this is the first and this is second. After taking two reflections, the light ray which is coming out, which is said to be RS, it is going to be the parallel to OM. This is going to parallel to OM. That is the question here. If these two are parallel, then what happens? Let us see here now. When these two are parallel, this is said to be 70 degrees. Why it is 70? These two are corresponding angles. If this is 70, this is also 70. These are called as glancing angles and they are going to be same. Let me discuss what is the meaning of glancing angle. For example, this is a normal, this is a mirror here. A light ray strikes in this direction and reflects back. Angle of incidence is there, angle of reflection is there. This is said to be glancing angle. This is also said to be the glancing angle. These two angles are same always. You just remember that concept. That means these two are going to be glancing. This is taken as normal here. Okay. So, therefore, these two are glancing. They are going to be same. And he's asking us to find out theta here. Let us see here now. This is 70, 70, it is going to be 140. And what is this remaining angle? We should find out now. This remaining angle is nothing but 180 minus 140, because angle sum property. The sum of an angles of a triangle are going to be 180 degrees. 70, 70 plus some other angle here. This is question mark. These three combined together should be 180. That is said to be ASP. Angle sum property. Let us see what is going to happen. If you want to find out this one, subtract 180 with 70 plus 70 is 140. We'll be getting 40 here. That means, what is this going to be? We got this as 40. We got this as 40. That means if this is 40, this is also 40. Because of glancing angles. Glancing angles are same. Now let us see 40 and 40. And this is the normal. That means as this is normal, theta plus 40 should be equal to 90. This plus this should be equal to 90. That means theta will be 90 minus 40. That is taken as 50 degrees. So therefore, that is going to be your correct answer. Your correct answer is going to be 50. That is this one. Hope you enjoyed this lecture regarding previous year. For full lectures, download the app which is given in the description. Thank you. My dear students, this is one more question regarding reflection. You can just see here, these are the mirrors present here. Okay, a light ray is incident at 50 degrees at the middle of one of the two mirrors. Means this is the middle point at one of the two mirrors. It is exactly making how much? What is an angle it is going to make here now? It is making 50 degrees. It is given in the problem that it is making 50 degrees among the two mirrors. And these two mirrors are making an angle of 60 degrees. It is given in the problem. Okay. So now a ray touches the second mirror. This light ray P, Q, R, it touches the second mirror. Again comes to the first mirror and reflects back. He is asking us to find out the angle of incidence of the first mirror here. This angle theta you have to find out. How are you going to find out this angle theta here? Okay. So for that, what you are going to do here now? 50 degrees. So this is 50 means definitely what is going to happen? So this is also 50 degrees. This is 50 means this is 50. And what is the remaining angle? As this is the normal here, this is going to be how much? 40 degrees. Because normal means 90 degrees. 50 plus 40 is going to be 90. So 60 plus 40 is going to be 100. So this is 100 means the remaining angle is going to be how much? 80 degrees. Because the sum of the angles in a triangle is equal to 180. So these three should be equal to 180. This is 80 means this is also going to be 80 degrees. Because these two are called as glancing angles. What does it mean actually? So this is a normal here. This angle, this is a mirror. This is angle of incidence, this is angle of reflection. These two angles are called as angle of glancing. These two glancing angles are going to be same always. That means this is 80 means this is 80. So 80 plus 80 is 160. But the remaining point is going to be how much? 20 degrees. Because 80, this totally completely it should be 180. So 80 plus 80 is 160 means this is remaining 20. So this is 40 means this is also going to be 40. These two are said to be glancing angles. Okay. These are said to be glancing angles. Now, if you consider this triangle, what is that triangle here? Triangle QRS. Okay. So triangle QRS. This also should have 180 degrees. Sum of an angles in the triangle is 180 degrees. That means what is the meaning here? You can just consider this complete angle. This complete angle is how much? 100 plus 40, that is 140. And this is 20. So 20 plus 140 is going to be 160. This is 160 means this is remaining is 20. Okay, 20 degrees. If the remaining is 20 degrees means what is this angle theta here? As this is going to be one more normal here. This 20 means this is going to be how much? It is going to be 70 degrees. Why? Because normal is making 90 degrees. The sum of these two is going to be 90 means if this is 20 means this is definitely going to be 70. So your correct option is the fourth option. Hope you have enjoyed this. My dear students, let me discuss a super simple shortcut for this type of problems, which are regarding concave mirror. This is a concave mirror. Object is placed at 15 centimeters, whereas he has given us the radius of curvature. He has given us the radius of curvature. And what is going to be the radius of curvature? The radius of curvature is 40 centimeters. If the radius of curvature is 40 centimeters, then focal length is going to be half of the radius of curvature, that is 20 centimeters. And now, object is placed at 15 centimeters first, and then it is placed at 25 centimeters. Okay? So, if object is placed at 15 centimeters, you may get the image somewhere here. And if an object is placed at 25 centimeters, you may get image somewhere here. Okay. So, let us see what is going to happen. You have to find out the distances between the two images. You have to find out the distance between the two images according to this problem. Yeah. So, let us see what is going to happen. So, for this, I'll tell you a simple concept. You all know 1 by f is equal to 1 by v plus 1 by u. This is a mirror formula. I know concave mirror means this is minus and this is also minus. That means 1 by v is equal to 1 by u minus 1 by f. So 1 by v is equal to f into u by f minus u. That means v is going to become fu by f minus u. You can use this shortcut formula. You can use this shortcut formula to find out the solution. Okay. Now let us see what is going to happen. First of all, he has given u1 as 15 centimeters. Substitute in this formula, that is v is equal to fu by f minus u. This is u1, so fu1 by f minus u1. F is 20 into 15 by 20 minus 15, that is 5. Okay. So we'll be getting answer as 60 centimeters. This is called as object distance v1. Second object distance you have to find out v2. And how much it is going to be? fu2 by f minus u2. Okay. So if you substitute here, you'll be getting how much? 20 into 25 by 20 minus 25. Okay. So this is 20 into 25 divided by minus 5. So we're getting how much? Minus 100 centimeters. You have to subtract these two. V1 minus V2. How much it is going to be? It is 60 minus of minus 100. It will be getting as 160 as an answer. 160 centimeters is going to be your answer. That's it. So what is the shortcut formula? Shortcut formula is this one. Fu by f minus u. If you remember, in two stages you get the answers. You just subtract them. Final answer is going to be 160 centimeters. Hope you have enjoyed this shortcut formula. Thank you very much. My dear students, this is a neat previous year question asked in 2020. What is the detailed explanation about this problem here? So there is a concave mirror whose principle of focus and center of curvature here. It is said that an object is placed at a distance of 1.5 f. That means this is f. This is a focal length and this is going to be 1.5 f. Object distance is 1.5 f. And he is asking us to find out what is the image distance. If this is an object placed between principle of focus and center of curvature, image is beyond C. If object is between F and C, image is beyond C. That means it is greater than object distance. How are you going to find out an image distance with a simple shortcut formula? Let us first create what is a shortcut formula here. So that is 1 by f is equal to 1 by v plus 1 by u. This is called as a mirror formula. Now, as focal length is going to be left side, it is considered to be negative here. Object distance is left side, it is also considered to be negative. Whatever you are going to find out, that is image distance, you should not consider any sign conventions, because answer will tell you the sign convention. Answer will tell you the sign convention. Only at f you have to take sign convention. You have to take sign conventions at u, that is object distance, but image distance you need not take any sign convention, because answer will tell you that it is at left side. Sign convention is given by the answer. Now let us see. So here 1 by minus f, here you need not, so this is minus sign you have to consider because left side. So now 1 by v is equal to, this comes to left side becomes positive 1 by f. So 1 by v is equal to LCM uf, which is nothing but f minus u. Therefore image distance can be taken as fu by f minus u. This is going to be our shortcut formula. Whenever you want to find out the problems of this type, you can just remember this formula. Need not write all the process and sign conventions. You can just write fu by f minus u. You will be getting the answer directly in a super simple way. So what is f? F is f. What is u? U is 1.5f. Divided by f minus u. F minus u. U is 1.5f. So this is 1.5 f square divided by minus 0.5, because f minus 1.5 is going to be 0.5. That's it. So here, are we getting now? See, this is 1 times, it is going to be 3 times. Here already one f is there, f square gets cancelled. So therefore, v is going to be how much? This minus comes to left side, upwards. That is, your answer is minus 3f. Is going to be your correct answer. Hope you have enjoyed this problem. Thank you very much. My dear students, this is a rotation of a mirror. What happens in the rotation of a mirror concept? Let us see. This is a mirror. It has been rotated to an angle theta. If it is rotated to an angle theta, how much angle the reflected ray is rotated? That means when the mirror is in this horizontal direction, then this is incident ray, this is reflected ray, this is normal. But when the mirror has been tilted through an angle theta, then instead of this light ray coming outside, you will get this light ray, and normal is not n now. The normal has been changed to n dash. When the mirror is tilted, normal also gets tilted through an angle theta here. And he is asking us to find out what is R Q R naught. He is asking us to find out this angle. So how are you going to find out this angle R Q R dash? Very simple. What you have to do here is, you have to find out, for example, you have to find out this R Q R dash. Then you have to take P Q R dash, this P Q R dash, and subtract. In this P Q R dash, you have to subtract P Q R, this angle P Q R. Then what happens? Let us see here. So angle P Q R dash is nothing but from here to here. If this is angle of incidence, this is angle of incidence and this is angle of reflection, both are going to be same. This is I means this is also I, when this is called as PQR. Incident ray is I and reflected ray is I. But when the angle is tilted by the mirror to an angle theta, then normal gets shifted. Then now the new incident ray will become I plus theta here. From here to here I plus theta, from here to here I plus theta. So I plus theta is going to be how much? I plus theta and I plus theta, because he has asked us to find out PQR dash. So PQR dash is nothing but I plus theta and I plus theta, which is nothing but 2I plus 2 theta. And you have to subtract PQR. This is I plus I, which is nothing but minus 2I. So 2I gets cancelled. What is left? 2 theta is left. That means this angle is taken as, this unknown angle is taken as 2 theta. Okay. Based on this concept, there is a previous year question. Let us see here. So this is a question here. When an angle of the mirror is rotated to an angle theta, then the light ray which is coming and falling on the mirror, it gets reflected through an angle 2 theta. 2 theta. Then he is asking us to find out what is this angle theta given by. So let us take this diagram as a sector. Let us imagine to be a small part of a circle sector. Then in this is 2 theta is written like this, and this is x and y. And you know, according to mensuration and geometry, arc of a sector is nothing but radius into angle. What is the arc here? Arc is nothing but y. And what is radius? Which is nothing but x. And what is an angle here? Which is nothing but 2 theta here. Okay. So this implies that theta can be taken as y by 2x. Y by 2x. Your option is going to be D. Hope you have enjoyed. Today we shall discuss about refraction. Okay. So before trying to solve these problems of previous year questions, we should have certain basic knowledge about refraction. So what is the meaning of refraction? Let me discuss in details here. For example, refraction means this is, let us imagine the denser medium, and this is imagine the rarer medium, and this is going to be the normal here. Okay, this is going to be the normal here. Now, when a light ray enters from rarer to denser medium, it bends towards the normal. This is said to be angle of incidence, this is said to be angle of refraction. This is said to be velocity of light in the first medium, and this is said to be the velocity of light in the second medium. So here, refractive index. What is the meaning of refractive index? What is the meaning of refraction? First of all, we shall discuss about what is the meaning of refraction. Refraction. Refraction is nothing but bending of light. Refraction is nothing but bending of light. When a light travels from rarer to denser, it bends towards the normal. Travels from rarer to denser, it bends towards the normal. And this bending is due to sudden change in the velocity. See, when the velocity of light is there in the rarer medium, like for example, here you take air as a rarer medium and water as the denser medium, so suddenly its speed decreases. And that's the reason why light ray starts bending here, isn't it? So that's why bending of light due to change in the medium is said to be refraction. Bending of light due to change in medium. Okay? Bending of light due to change in medium is called as refraction. Understand? So here, in this refraction, how many types of refractions are there? Did I explain about that? How many types of refractions are there? Types of refraction. Generally, there are 2 types of refraction here. What are the refractions here? Types of refractions. One is said to be absolute refractive index. One is said to be absolute refractive index. Other is said to be relative refractive index. Absolute refractive index, relative refractive index. What is the meaning of absolute refractive index and what is the meaning of relative refractive index? We shall discuss in details. See, in absolute refractive index, always rarer medium is air or vacuum. Okay, rarer medium if you consider as air or vacuum always, and some other denser medium, any denser medium you can take. And velocity of light in air or vacuum is always c. Okay, it's going to be always c, and here velocity of some other medium is taken as v here. This is said to be always absolute refractive index. Absolute refractive index means always comparing any other medium with air or vacuum. That is said to be absolute. Absolute. Always comparing any medium with air or vacuum. No other mediums. Now when you consider a relative refractive index here, when a light bends like this, and always when you take here, this is medium 1 and this is said to be medium 2 here. Okay, when it is said to be medium 2, this is velocity of light in the first medium to the velocity of light in the second medium. First medium, second medium. Any mediums you can take. Any mediums you can take. That is said to be relative refractive index. Absolute and relative, that is the difference here, no? Okay, so what are the formulas here? Let me discuss about the formulas here. See, absolute refractive index means any medium with respect to air, which is always taken as C by V, which is always considered as C by V here. Now, just here, this is said to be absolute refractive index. Always numerator is C and denominator is V, but here absolute relative refractive index means refractive index of second medium with respect to first medium. Any mediums we can take. So that is taken as velocity of light in the first medium to the velocity of light in the second medium. So here, this relative refractive index is having two absolute refractive index combinations. That is mu21 is considered as mu2 with respect to air, mu1 with respect to air, which can be considered as here absolute refractive index air with second medium means C by V2. Same, air with some other medium means C by V1. Understood? So CC gets cancelled. What is V1 by V2? So that's why this is said to be relative refractive index. Relative means two other mediums. Absolute means always medium with respect to air. So relative refractive index is a combination of two absolute refractive index. I'll give one best example for you. For example, if I ask what is your marks, you say, sir, I got 90% out of 90 out of 100. You say this is said to be absolute marks. You got a good marks, then you say, sir, I got 90%. Oh, sure. Excellent marks I got. That is 90%. That is absolute. Always comparing with 100. When you get less marks, then you will compare with your friend. That is said to be relative marks. Then you say, sir, I got 70, but my friend got only 60. You compare to escape from your parents. Understand? You compare with your friends. Then father will tell, sir, what is this nonsense? You got 30 marks less. Don't tell about your friend. I want your marks. You got just, so what is this? This is said to be relative marks. Relative marks is nothing but the combination of two marks, no? Two absolute marks, which is 60, 70 out of 100 and 60 out of 100. Two absolute is going to be relative. Understand what I am telling you? But there, 100% is in the numerator. Velocity of light is maximum in air or vacuum, and it is less in some other medium. Hope you are understanding what I am saying. So that is the meaning of absolute and relative refractive index. So once you understand this one, then the total concept of refractive index is refractive index of medium 2 with respect to medium 1 is nothing but velocity of light in medium 1 to the velocity of light in medium 2. This is the first formula. And what is the second formula? The second formula is distance traveled in the first medium to that of time and distance traveled in the second medium to that of time here. Is it? Okay. This is another formula. The next formula is velocity is taken as n lambda 1 by n lambda 2. This is the second formula. This is the next formula. Why? Because we all know velocity is nothing but n lambda. So when a light enters from one medium to another medium, the waves, light is nothing but a wave. Okay? Frequency is constant. Frequency is constant. Frequency does not change from one medium to another medium. N is going to be constant, but wavelength will change. Wavelength will change. When velocity decreases, wavelength also decreases. Wavelength also decreases. Okay? Here the greater wavelength means in the denser medium wavelength will become less. Understand what I am telling you? So this is one more formula here, is it? There is a one more formula. The next formula is sin A by sin R, which is also called as Snell's law. What does it mean actually? For example, light travels from one medium to another medium. This is angle of incidence. This is angle of refraction. We write as refractive index is nothing but sine of angle of incidence to that of sine of angle of refraction. Sine of angle of incidence to that of sine of angle of refraction. Understood what I am telling you? That is said to be the refractive index. Is it okay? Is it understood to you? So that is about the refractive index here. Okay, these many formulas are there. Next, one more formula here is real depth and apparent depth. What is the meaning of real depth and apparent depth? Let us imagine here, okay? So I am taking so let us take a beaker in which water is present here. taking one coin here. Okay, I am seeing from here. I am seeing from this end. This coin appears to be little bit raised. You are seeing and light ray just bends like this. I told you that when it travels from rarer to denser medium, it is air here, isn't it? It is water here. It travels from air to water, it bends like this. It bends like this. It bends towards the normal. But when you make this straight, okay. Now just here. What is going to happen? Now the coin appears to be a little bit raised. When you keep any coin in a bucket or a tub, you feel that the coin has been little bit raised. How much it is raised, we shall find out. So this is said to be the shift of the coin. And what is this going to be? This height is going to be h dash. Okay. And the total height of a tub or depth of the coin inside the tub is taken as h. This is the complete h height, a complete depth, and this is somewhat raised here. Okay. Then what is this? This is said to be x shift of a coin. Coin has been shifted here, shifted upwards, little bit upwards, because this is said to be line of sight. Okay. So you are seeing in a straight line. That's why the coin appears to be a little bit raised when it is kept inside the bucket. But when you try to catch the coin, there won't be any coin there. That is said to be apparent depth. It's not a real one. It appears to be a little bit raised, but it's not a real depth here. Okay. So what are you going to do? Let us see here now. This is angle of incidence means what is this? This is R means this is also R here. These are said to be alternate interior angles. This is R means this is R. This is I means this is also I. These are said to be corresponding angles. This is alternate interior angles. These are said to be corresponding angles. Okay. So what is going to happen? Let us see here now. See, refractive index formula is sin I by sin R. Or it can also be taken as tan I by tan R. For small angles. For small angles, if you consider, sin theta can be approximately taken as tan theta. For small angles, sin theta approximately equal to tan theta, which is also equal to theta. Understood? So that is said to be refractive index. Tan I by tan R, sin I by sin R. Tan I means what I am going to consider. Let us see here now. Tan I. So let us take this as distance AB. Okay. So tan I means opposite side is AB. Adjacent side is how much? H dash. And tan R means opposite side is again AB. Tan R. Adjacent side is how much? H. Understood? I means AB by H dash. R means AB by H. Opposite side by adjacent side. So here AB gets cancelled. So refractive index, what is left? H will go to the numerator and H dash is in the denominator. So refractive index is H by H dash. H means what? It is said to be real depth. And that is said to be apparent depth. Real depth by apparent depth. This is another formula. This is one more formula. Real depth by apparent depth. Okay. So now just here. So if any coin is placed inside a bucket, it appears to be little bit raised. This is the surface. Okay. And what is this going to be? H. And what is the remaining? It is H dash. Am I right or not? Okay. So I told you that refractive index is nothing but H by H dash. And what type of refractive index it is? It is said to be absolute refractive index. Okay. It is said to be absolute refractive index. Refractive index of a medium with respect to air always. Because light is traveling from air to water. Understand? So that is said to be H dash, H by H dash. Now I would like to find out what is the shift here. How can you find out the shift here? Refractive index is H by H dash, which is said to be real depth divided by apparent depth here. Okay. So refractive index is real depth by apparent depth. I would like to find out what is the raise shift. X is said to be shift here. Okay, how can you find out this shift? Let us see here. X, if I want, what I have to do? I have to take h minus h dash. Is it? H minus h dash will give you x or not? Okay, then here refractive index, I already told you it is h by h dash. If I want to find out h dash, what I will do? H dash is equal to h by mu. H dash is equal to h by mu. Okay, so what I am going to do now? I will write h like that only. Minus, instead of h dash, I am writing h by mu. Okay, so x is equal to h if you common out 1 by 1 minus mu is going to be the formula for shift. Understood? This is the formula for the shift here. Is it clear what I am saying? This is the formula for shift of the coin. Okay, and this is applicable for even glass slab also. For example, I am taking a glass slab here. Okay, I am taking a glass slab. Below the glass slab, let us imagine there is an object here. Okay, and I am seeing from above. Let us consider thickness of the glass slab is T. Thickness of the glass slab is T. This coin appears to be little bit raised here now. Okay, this is said to be shift of a coin. In a glass slab also, this is said to be a glass slab. It appears to be little bit raised. So how are you going to find out the shift? Same formula. X is equal to, as you know the formula is x is equal to h into 1 minus 1 by mu. But instead of h here, I am not taking to a real height, I will take thickness. Instead of h, I will take t here. That is t into 1 minus 1 by mu. Okay, that is said to be shift here. Shift of a object inside a glass slab when it is kept below. Is it understood or not? So that is said to be shift of a object when you keep a glass slab above the any object. No, that is said to be shift here. Okay. So now let me discuss about what is the meaning of critical angle. What is the meaning of critical angle? So let me discuss about what is the meaning of critical angle. So here there is a water. So this all water is present here. Okay. Now you have kept an object at this place. There is an object here. And you are the light ray from the object source. Okay, you can consider this as a source of light you observe. So light travels from here to here, from here to here, and from here to here. I am drawing the normals here. Let us consider this is normal N1, normal N2, normal N3, normal N4. Okay. What is going to happen now? This is said to be angle of incidence I1. This is said to be angle of refraction R1. This is said to be angle of incidence I2, and light ray will bend a little bit more here because it is more steeper. No, I will increase means R also will increase. This is R2. It is more steeper, so steeper that this is taken as R3, which is equal to critical angle. Why critical angle? Because the light ray exactly passes from the surface here, exactly grazing on the surface. Then at that time, angle of incidence R3 is said to be critical angle, and this is said to be R3, which is said to be 90 degrees now. Beyond the critical angle, if light travels, then what happens? It will reflect back, and this is said to be angle of incidence, angle of reflection. This is said to be okay. Now just this is said to be critical angle, and what is this? This is said to be total internal reflection. The light ray is entering from water, touching the surface and reflecting back. This is said to be total internal reflection, that is said to be PIR. Total, whatever the light will travel, it will not go to the air medium, it comes into the denser medium only. It comes from water and again returns to the water itself. Okay, so this is said to be the denser medium, touches the denser medium and again returns back. And that's what is said to be total internal reflection. I think you understood what is the critical angle. Now let me discuss what is happening here. Refractive index, this is the first medium, this is the second medium. First medium means from where the light starts. Second medium means where light ends. This is said to be superscript to subscript. Superscript is always the first medium. And what is the first medium here? Refractive index, first medium is water. And second medium is traveling from water to air, no? Is it? So, and if you take sine of angle of incidence, is taken as, okay, this is I3 here. This is I3, that is R3, no? This is I3, which is equal to critical angle, that is R3. Angle of incidence, light travels, it bends away from the normal because it is traveling from denser to rarer, it bends away from the normal. Denser to rarer, it bends away from the normal. Denser to rarer, again it bends so much that the light ray grazes. The light ray grazes from the surface. Is it understood? Now if there is no chance of again grazing also, it will return back. There is said to be total internal reflection. So first medium, what is that? Critical angle. Second medium, sine of angle of incidence is what? Sine I3 by sine R3. Is it? So sine I3 is sine C, sine R3 is sine 90. Understood? Which is equal to mu W by mu A. Is it? First water is coming, then air is coming. Then what I am going to get now here, you can just see. So refractive index of water with respect to air is sine. What I am getting now, just see. Sine C by sine 90. Sine C by sine 90. You know sine 90 is 1, is it? Sine 90 is 1. But if you want to change superscriptive and subscriptive, then what you have to do? Refractive index of water with respect to air is nothing but 1 by refractive index of air with respect to water. Is it understood? Then what you will get? This is sine C. Understood? Sine C like that only. So I am converting ordinary refractive index into absolute refractive index. If I want the subscript to be superscript and superscript to be subscript, I have to take reciprocal. I take reciprocal. So I have taken reciprocal, now it is sine C. Now if you want to find out the critical angle, sine C is equal to 1 by mu. Okay, 1 by mu. Refractive index of water or any other material. Absolute refractive, when you are representing, no need to write air and water here. Absolute, no? 90% means over. It is already understood is 90 by 100. So you can write 1 by mu. So this implies that if you want to find out the critical angle, what it is going to become? Sine inverse 1 by mu. That is said to be critical angle. Understood? Is it okay?
Yes.
So this is said to be critical angle. Okay. And what is this? Mu is what? Mu of water with respect to air. Mu of water with respect to air, what does it mean actually? Light is traveling from air to water. Air means C by V. C by V. So mu means C by V. C is velocity of light in air. V means velocity of light in vacuum. Water, sorry. Some other medium. So what I am going to write now here? Refractive index. Mu, which is nothing but mu only, no? Air with respect to water only here. We can write air with water with respect to air only. Absolute only, no? This one.
Yes.
That is taken as C by V. That is taken as C by V, which is equal to mu here. So what I am going to get now? C is equal to sine inverse of mu. Mu means V by C. Okay. That means we can also write from this sine C is equal to 1 by mu with respect to water and air. Okay. So this can also be written as 1 by C by V. Therefore, sine C critical angle is nothing but V by C. This you have to remember. Sine C means V by C. Reverse, not C by V. Critical angle means velocity of light in a medium to that of velocity of light in a some other water. Purely water. Air, no? C means velocity of light in air. V means velocity of light in any other medium. Is it clear?
Yes.
That is okay. So this is about the critical angle. Now we can solve any problem. Now just see here. Now just see here. Now let's see. So this is a, let us consider here, this is said to be air and this is said to be water, some other medium like this. A light travels distance x in time t1 in air. This is distance how much? Distance x1 and time is t1. Okay, in water how much? Distance how much it is traveling? 10x and time is t2. In another medium. What is the critical angle for this medium? What is the critical angle for this medium? What is the formula of critical angle? Just now I told you. What is the critical angle formula? C is equal to V by C. C is equal to sine inverse of V by C. No? So what I am going to get now? Okay. C is equal to sine inverse of V by C. Huh? So what is the meaning of V? V means distance by time. That means x1. V means medium now. Water. V means medium. So in water what is happening? Distance 10x by t2. C means here. This is in medium. C means x1 by t1. Okay. Velocity in medium is 10 times. Is it clear? So that's the same thing I am doing here. C means sine inverse of V. V means 10x by t2. And this is x by t1. So x gets cancelled. What is left now? Sine inverse of 10 into t1 by, this is t2. Okay. C is the correct option. Understood all of you? Let us go for the next concept. See, two transparent mediums are there here. Two transparent mediums are there. Okay, this is medium A and this is medium B. Two transparent mediums A and B are separated in a plane boundary. The speed of light in these mediums are given like this. Okay, here speed of light is V1, which is 1.5 into 10 power 8 meters per second. Understood? And what is another medium here? Let us take the other medium in which velocity of light is greater. Is it? And then it is greater. Greater means, what is the meaning here? What is the meaning of greater? Here speed is increasing, no? Speed is increasing, this is rarer. And this is denser. It is traveling from denser to rarer. Means it is traveling from here, it bends away from the normal. Understood what I am telling? It bends, rarer to denser always bends away from the normal. Denser to rarer bends away from the normal. Rarer to denser bends towards the normal. Understood what I am saying? So that is happening here. So denser to rarer bends away from the normal. I, R. Is it okay? So here in denser medium speed is less. It is given V1 is equal to 1.5 into 10 power 8. In some other medium V2 is equal to how much? 2 into 10 power 8 meters per second respectively. The critical angle for the ray of light for those mediums, critical angle means what? If this is taken as a critical angle, then it has to graze like this, isn't it? Then denser medium, no? Always critical angle is in the denser medium only, not in the rarer medium. Critical angle will be always in the denser medium. So what I am going to say now, so C is nothing but sine inverse of, okay, what I am going to get, V by C I told now, means velocity in denser medium to that of velocity in a rarer medium. Is it okay? This is the formula we are getting now, sine inverse. So C is equal to sine inverse of first denser medium. What is the denser medium? This is the denser medium. So V1. Rarer medium, V2. Is it clear? So what I am going to get now? V1 means 1.5. V2 means 2. Is it okay? So from this 50% of 1.5 is 0.75. Is it understood? So then the answer is going to be how much? See, V1 by V2 is nothing but 0.75. So sine inverse of 0.75. 0.75. Is it okay? Now, that is the question here. If the critical angle for the total internal reflection for a medium to the vacuum is 45 degrees, then the velocity of light in the medium is how much? See here, critical angle is given as 45 degrees. Then the velocity of light in the medium is how much? Is asking. Okay. So, what is the formula actually? Sin C is equal to? Sin C is equal to, what is the formula actually? Sin C is nothing but V by C. Just now we got it. V by C. So sin C is nothing but sin 45. Okay. Velocity of light in the medium. He's asking us to find out velocity of light in the medium, no? V is asking. C we already know 3 into 10 power 8 meters per second, and this is constant. Velocity of light in vacuum is not going to change. It is the same here. So 3 into 10 power 8. Okay. And what is this sin 45? Sin 45 means 1 by root 2. Understood? Is it clear? So 1 by root 2. So what is V here? V means 3 into 10 power 8 by root 2. So what is the correct option? D. 3 by root 2 into 10 power 8. Understood? Okay. Now just see here. An air bubble in a slab having a refractive index. There is a slab. This is a slab actually. Slab means it will be like this. Understood? Slab. Just like dice. You know, you are playing dice. But dice is not transparent. Let us take glass slab. Dice which is transparent. Some keychains are there which are transparent. Have you seen or not? That type of dice is you are considering. An air bubble is in a glass slab. Okay. There is an air bubble here. Let us imagine. There is an air bubble here. Glass slab is having a refractive index how much? 1.5. Is it? Normal incidence. Air bubble in a glass slab with a refractive index 1.5. Near normal incidence is 5 meters deep viewed from one side. From here you are seeing. Okay. When you see from here, it is 5 centimeters depth. Okay. And if you see from other surface, how much it is? 3 centimeters depth. Understood? From the opposite face. From here if you see. From here you are seeing 5 centimeters. From there you are seeing 3 centimeters. Then the thickness of the glass slab means total thickness is asking. Is how much? Okay. The simple shortcut is, I told you. Refractive index is real depth by, real depth by apparent depth, isn't it? So what is that refractive index given here? 1.5, no? Is it? 1.5 or 3 by 2, both are same. Real depth means how much? Total thickness. Total thickness I will take. Here apparent depth means 2 apparent depths are there. Is the apparent depth? Is the apparent depth. Real depth is this much. Okay. Understood what I am saying? So what I will do now? 5 plus 3. Is it understood? So how much it is going to be? Then just see. 3 by 2 is equal to t by 8. 2 ones are 2 fours are. This implies that t is equal to how much? 12. Okay. This is said to be 12 in centimeters. Understood all of you? So we are discussing about the prism here now. Prism gurinchi discuss here. So if you want to discuss about the prism, let us go in details about what is the prism, how does it works. Okay. So we shall discuss about what is the prism and how does it works. So this is a prism. I am drawing a normal here. I am drawing another normal from here. Okay. So this is a normal N1. This is normal N2. Now just see what's going to happen. So light travels from this point. This is P and this is Q. And it is traveling from air to glass. This is prism which is called as glass medium. And it bends towards the normal like this. And it comes out. Understood what I am telling? See here, when it travels from air to glass, it bends towards the normal. When it travels from glass to air, suppose consider this is a prism. This is a prism ABC. Okay, a triangular prism. A light ray travels from rarer to denser air to glass. It bends towards the normal. This is the normal N1, and travels from denser to rarer. It bends away from the normal. Okay, so what is this going to be? I1. This is R1, and this is the refractive index R2. This is taken as I2. But what is the meaning actually? The light ray has to travel like this, but it is bending like this, no? What is this said to be? This is said to be deviation, angle of deviation. Means like this it has to travel, but it is traveling like this. That is said to be angle of deviation. Now, so here, this is I1, this is R1. Means actually these two are vertically opposite angles. No, what is the remaining angle now? I1 minus R1. This I1 means this is also I1 only. Vertically opposite angles are same. But what is the remaining? I1 minus R1. Here this is also, this is I2 means this total angle is I2. But R2 if you remove from I2, it is going to become I2 minus R2. Is it okay? So now what is going to happen? P, Q, and this is R and this is S. Let us imagine this is T and this is U here. Is it? Okay. So this is about the prism here. This is about the prism. Construction of a prism. Now we are finding what is the refractive index of a prism. How does this prism works? What is the refractive index of a prism here? For that, what I am going to do first, let us take case 1 here. Case 1. What is case 1? I am going to take a triangle. I am going to consider triangle TQR. Triangle TQR. If I consider triangle TQR, exterior angle, that is delta, is equal to I1 minus R1 plus I2 minus R. Okay, exterior angle delta is equal to I1 minus R1 plus I2 minus R. So therefore delta is equal to I1 plus I2 minus, if you common out, R1 plus R2. Is it okay? That is taken as delta here. Okay, what is the meaning of delta? Deviation. Deviation we are getting like this. Is it? So let us take this as equation number 1. Next we shall discuss about what is case 2. Case 2. Case 2 we shall take here. We shall consider triangle QUR. Triangle QUR. In this QUR, I can take R1 plus R2 plus U is equal to 180. Can I take this? R1 plus R2 plus U. Angle sum property. Sum of the angles in a triangle is said to be 180 degrees. Sum of angles in a triangle is said to be 180 degrees. That is 180 degrees here. So, what I am going to write to this one? R1 plus R2 is equal to 180 minus U. 180 minus U. So, this is taken as equation number 3 here. Okay, case 2 is over. Now, let me discuss about what is going to happen in case 3. Case 3, if you consider, I am considering here the triangle total quadrilateral. So quadrilateral AQUR. AQUR. Understand? So what is this quadrilateral AQUR? See, angle A plus angle AQU. See, what is this AQU? Is it not 90 degrees? Normal is it?
Yes, sir.
So AQU means 90 degrees. Plus angle U plus again ARU. This is normal. That is also 90 degrees now. So plus 90 is equal to how much? Is equal to 360 degrees. All the angles in a quadrilateral, sum of the angles in a quadrilateral is 360 degrees. So 360 degrees I am writing now. So I will write A plus U is equal to 360 minus 90 plus 90 is 180. So 180. So A plus U is equal to 180 degrees. So A is equal to 180 degrees minus U. This is equation number 4. Understood? So if you compare these two, RHS are same, no? 180 minus U, 180 minus U. What I am going to get now? R1 plus R2 is equal to A. This is very important. This equation is very important because it is used in problems. This is used in solving the problems. What is that? R1 plus R2 is equal to A. Now what I am going to do? Here, Substitute 5 in 1. This you substitute here. So delta is equal to I1 plus I2 minus R1 plus R2 is equal to A, no? So here we write A. So I1 plus I2 is equal to A plus delta. Understood? So what I have done just R1 plus R2 is equal to A, no? Here I am writing A. So there I have written A, but I1 plus I2 is equal to A plus delta. Understood? So I am getting this equation. This is also very important. It is also used in solving the problems. Okay? It is also used in solving the problem. This is equation number 6. These two are very important in solving the problems. Now, there is a condition which is called as angle of minimum deviation. There is a condition where it is called as angle of minimum deviation. Angle of minimum deviation means what? Angle of minimum deviation means symmetry occurs. Means, here if you draw a line like this, in the exactly middle if you draw a line like this, okay? So exactly in the middle if you draw a line like this, symmetry vastundi. Symmetry means the angles this side and angles that side will be same. Okay? So what is going to happen when symmetry comes, we shall discuss here. When symmetry comes, what happens, let us discuss here. At minimum deviation, what is going to happen? Symmetry occurs. When symmetry occurs, what is going to happen? First thing is delta will become delta minimum deviation. Minimum. Next, what is going to happen? I1 will be equal to I2. Symmetry occurs means these two angles will be same now. I1 is equal to I2 is equal to I. And these two angles are same, R1, R2. R1 is equal to R2 is equal to R. That's it. Is it okay? Now I1 is equal to I2 is equal to I. R1 is equal to R2 is equal to R. If you substitute this one here, what I am going to get now? Just see. R1 means R. R2 means R. Is equal to A. That means this is 2R is equal to A. R is equal to A by 2. Understood? So I am getting R is equal to A by 2 here. Now this is I1 is equal to I2 is equal to I. Here if I substitute, I1 means I, I2 means I. A plus delta means minimum deviation. A plus delta minimum. So this is 2I is equal to A plus delta minimum. I is equal to what? A plus delta minimum by 2. Understood? Is it clear? So I got I is equal to A plus delta M by 2, R is equal to A by 2. I want refractive index now. So refractive index means what? General formula is sin A by sin R. Snell's law. We call it as a Snell's law. So mu is equal to sin I. What is sin I now? Sin A plus delta M by 2 by sin R means sin A by 2. Okay. So what is this called as? This is called as refractive index of a prism ki formula. This is said to be refractive index of a prism. Sin A plus delta M by 2 by sin A by. Understood? Clear? That is about prism. Is it clear? So once you understand the prism, it's very easy to solve the problems of the prism. Okay. So I got this formula. Now we shall discuss about what is the meaning of thin prisms. What is the meaning of thin prisms? So I am considering a very thin prism like this, very sharp. Okay. So and what is the refractive index formula? Sin A plus delta M by 2 by sin A by 2. This is said to be the general formula of a prism. For thin prism, when the angles are very small, sin theta approximately equal to theta. Then what I am going to get? Sin theta is approximately equal to theta means sines will not be there for small angles. Thin prism means small angles, that is understood. Thin prism means small angles. So small angles, sine will not be there. Now 2 gets cancelled. What is left now? A is equal to, mu is equal to sin A plus delta M by 2 by A. So A plus delta M is equal to mu into A. So delta M is equal to mu A minus A. So therefore delta M is equal to mu minus 1 into A. Understood? So thin prism refractive index, if you want to find out, this is going to be the shortcut formula. You should remember this one. Okay? Thin prism formula. There is one problem which is related to thin prism. We should discuss about that problem also. here. A glass prism is having refracting angle. How much? 10 degrees. A glass prism, a thin glass prism, refracting angle at 10 degrees. Okay. And what else? Refractive index is 1.42. Is combined with another glass prism. Rendu glass prisms and formula will change. Okay. So there is one more thin prism here. Okay, another thin prism. This is first one. Okay, mu1 is 1.42 and A1 is how much? 10 degrees. Is it okay? A1 is 10 degrees. Next, another thin prism is combined together. Okay, so another thin prism is combined together without deviation. Deviation is not there. And what is given? Refractive index of the second prism, which is this side, is how much? 1.7. Okay. And what is asking us to find out? Angle confirm. The angle A2 is how much? A1 is given, A2 is how much? Is it understood? Okay. So what is the formula which you have derived now? Mu is equal to, what is the formula we have derived? Huh? Mu minus 1 into A. Understood? Sorry. Deviation. And then deviation delta is equal to mu minus 1 into A. And what he is telling here? Without deviation or not. Deviation ledanta. It is middle. What is left now? This is left. That means A is inversely proportional to mu minus 1. Okay. So A2 by A1 is equal to mu1 minus 1 by mu2 minus 1. Inverse relation, no? So A2 how much? A2 is how much here? A2 we don't know, we have to find out, isn't it? So this implies that A2 we don't know. What is A1? 10. And mu1 minus 1, 1.42 minus 1 by mu2 minus 1, 1.7 minus 1. So what is left now? So A2 by 10 is equal to 1.42 minus 1 means 0.42 divided by 0.7. Understood? So A2. So what is there now? So if you remove this point, sir, multiply with the 10 on both sides, sir. This is 70 and this is 42 and 70, okay? So 7 10 is 70, 7 6 is 42. A2 is equal to 60 by 10. 10 gets cancelled. 10 10 ikkade poyindi. Direct 6 వచ్చేస్తుంది. Answer is 6. Understood? So this is one application. Now just here, another problem. You are taking a prism. What is the refractive index of a prism? Root 2. Angle of a prism 30 degrees. One of the two refracting surfaces of the prism are made up of mirror, means this side you are silvering. Okay, it is made up of mirror inwards by silvering coating. A beam of light is entering into the prism from the other face and retraces its path. Means what is the meaning of it? Let us see. So ikkada nunchi oka light ray veltundi. It strikes that side and again retraces back. Means ఏ దారిన వస్తే ఆ దారిన వాపస్ వచ్చేస్తుంది. It strikes the mirror and returns in the same direction. That is the meaning of it, isn't it? So you can consider this. This is the normal here, no? Normal. What is this? Angle of incidence I1, R1. Here, this is striking and, for example, mirror is not there means it has to go straight, no? So anything is going straight means what is the meaning? I2 is equal to R2 is equal to 0. Straight to both. No refraction, no incidence. It is going perpendicular to the surface. Then only it retraces back. Why it reflects back? Anything you strike exactly, ball you strike exactly perpendicular to the wall, it comes towards you. Exactly perpendicularly. Retracing and the ये दार में कोई तो कौन से रास्ते से गया वही रास्ते से वापस आना. That is said to be retracing back. Is it clear? So retracing back means R2, I2 is going to be 0. What else? The data given. Okay, that's it. So what is asking? Find the angle of incidence. It is confirmed. I1 is asking us to find out. What is the answer here? Let us see. First thing is, the main formula from the prism is R1 plus R2 is equal to A, no? So R1 plus 0 is equal to A. That means R1 is equal to A, means 30 degrees. Understood? Is it understood? Refractive index is also given, which is root 2 in the problem itself. Here. So what is mu? Mu is equal to sin I1 by sin R1. What is mu? Root 2. What is sin R1? I don't know sin I1. but sin R1 is sin 30. Okay, so sin I1 is equal to root 2 into sin 30, means root 2 into 1 by 2. So this can be cancelled now. Okay, root 2 is equal to root 2 into root 2. Okay, root 2 was root 2 million, which is equal to 1 by root 2. So, very good. 45 degrees. So that is going to be I1 is 45 degrees. That's the answer. Is it understood? Is it clear? Okay, we shall stop here. My dear students, you can just see this problem. This is a previous year problem asked in NEET. How can you solve this problem? You can just see this is a coin. A light ray enters outside the water and it is grazing through the surface. It is grazing through the surface. That means that if you draw a normal here, that means this is going to be a critical angle. If you are drawing a normal here, this is going to be a critical angle. If this is a critical angle, this is also critical angle, because when you draw these two parallels, alternate interior angles are going to be same. This is C, means that is also C. You all know the formula for refractive index. Mu is equal to, if it is a case of critical angle, you write mu is equal to 1 by sin C, and you also know that refractive index formula is velocity of light in air to that of velocity of light in water. That's it. Your formula is ready. You will get the answer in a super simple way. Now you will write 1 by sin C. This is going to be sin C. So sin C is nothing but opposite side by hypotenuse. This is 4, this is 3, this is 4, means this is 5. According to Pythagoras theorem, 3, 4, 5. Sin C is nothing but opposite side is 3 and this is 5. 5 means you can write this 5 in the numerator, and this is going to be 1 by C by V. What is C? You all know C is nothing but 3 into 10 power 8 divided by V. Okay, so he is asking us to find out V. It's very simple. You can find out V. Now take this 5 by 3 is equal to 3 into 10 power 8 by V. You can find out the value of V, and you'll be getting the value of V as 1.8 into 10 power 8. That's it. So simple it is. No need to worry. My dear students, this is a previous year question of NEET. Okay, you have seen the mentioned year also. You can see there is a air bubble inside here. There is an air bubble here at this place. Okay, now from this side, if you see, the bubble appears to be closer, and that too it is 3 centimeters. From that side, if you see here, okay, it appears to be 5 centimeters. Okay, then what is the thickness of the cube? That is the question actually. You can just see the question solution given in the books. It requires 3-4 steps here to solve the problem, but I am going to tell you a shortcut method so that you can solve this problem in a single step here. Okay, so what is that single step method? Let us discuss about that, isn't it? So refractive index is given as 1.5. So I'll tell you that. Okay, this is taken as it is taken as real thickness by apparent thickness. Mu is equal to real thickness by apparent thickness. What is the real thickness? We have to find out. So real thickness is equal to mu into apparent thickness. And what is mu? It is 1.5, can be written as 3 by 2. Into apparent thickness means you can take 3 plus 5. You have to take this apparent height and that apparent height. That is 3 plus 2, 5, that is 8. So this is taken as 2 4s are 8, 4 3s are 12 centimeters. Is it not a shortcut method? In which chapter you need a shortcuts? You can just comment below. If I find anybody's comment useful and worthful, then I am going to give you a free ebook for you for these shortcuts. I'll give 100 shortcuts ebook for you, free of cost. Okay, if you mention your WhatsApp number also. Thank you very much. My dear students, don't swipe. You may miss a wonderful physics short trick for NEET 2024. Just remember. See here. The problem says that light ray enters and it deviates. It is refraction. It is said that angle of incidence is double to that of angle of refraction. In such situations, he is asking us to find out what is mu. That's it. Sorry. What is I? He is asking us to find out what is I. How can you find out that one? Snell's law says that mu is equal to sin I. Here sin I means sin 2r by cos sin I by sin r. So this is sin r. That's it. Here this sin 2r means 2 sin r cos r divided by sin r. Sin r gets cancelled. What is left now? This is mu. So you know that cos r is equal to mu by 2. Cos r is equal to mu by 2. This implies that r is equal to cos inverse of mu by 2. But he is asking us to find out what is I. And you know I is nothing but it is double to that of refraction. Therefore 2 into r, there is, right, 2 cos inverse of mu by 2. So simple it is. Hope you have enjoyed this.